Good afternoon. Yeah, you all heard about Michael. He's gravely ill at the moment. I hope he will get better. I also would like to thank Larry White and his wife Peggy Bean, who have taken the responsibility of helping him through this difficult time. So, in stepping in for him, I would try to do my best to give the presentation in a way he would have wanted it to be. Okay. This is not working. Oh, next slide, please. Okay, thanks. So this again here is not doing what it should do. Okay, so we start this talk about catastrophic geology with myth and legend. The reports we have from various cultures, it's not just one report, it's several reports, which makes it kind of hard to dismiss. The picture all those reports are painting is the following. There was a time of darkness. There was dust so thick you couldn't see. There were winds so fierce you could not stand. Rocks were falling from the sky, sometimes the size of trees. Also gravel and oil was coming down. Rocks mingled, so they called it, with the river of fire. It was a time of mountain building and removal, so it's said. The agent of this kind of catastrophes and catastrophe was Venus, the comet Venus, as it was popularized by Immanuel Velikovsky in Worlds in Collision. Also, there has been talk about the sun setting where it used to rise. If we would take that literally, it would mean that the Earth would have reversed its rotation. So this, an incident like this, we call it an incident, would release the roughly 13-mile-high bulge of seawater at the equators because of the missing centrifugal forces. So those waters would be rushing north and south to the poles. Depending on the rate of deceleration and again acceleration, there would be also, of course, an east-west component in the waters rushing. This kind of event Michael calls a sloshing event. This might sound crazy to you, but I mean, look around you, so is the geology of the Southwest. Also, those legendary scenarios kind of start to make sense again once you look at them through the electric universe paradigm. Because they have recent catastrophes on a scale that is nearly imaginable. The EU model has a different set of assumptions from the standard model, of course. I will not discuss those set of assumptions. The aim here is about the explanatory power of the model. So, yeah, and now I would like to see the next slide.
Okay, well, we're going to have to take a technical 5 minutes here. Sorry,
Okay.
Michael. And we'll get this straight up because you absolutely need to see these images. They're
Exactly.
the work of a brilliant photographer, and his eye is going to show us a lot. So we're going to give him about 5 minutes over there in the booth to get us untangled and back, bring it back down to earth.
Get up by here. Okay. Okay, let's continue. So this was the slide I would have shown you. By the way, this is Shiprock, close to Four Corners. Beautiful site. I can only recommend it. Okay, so now let's dive into the geology of the Southwest. First example is Grand Canyon. The Colorado River goes through it. It's about a mile deep. If you look at it from above, it looks like this. The north rim is up here. Is roughly 1,000 feet higher than the south rim, which is down here, which again is roughly 1,000 feet higher than the surrounding area down here. So the standard model has the Colorado River going and eroding basically the Colorado Plateau while the plateau is rising. Somehow the river always managed to erode away just enough so that the rise was counteracted. And because if that happened once, it would have gone around it to the south, as I mentioned before, because it's 1,000 feet lower than the actual rim of the Grand Canyon. So that's kind of an odd model, I think. Even some ideas within the EU community, like this being created really initially by a Thunderbolt, I personally find a little bit odd because this would mean that the Thunderbolt actually went through the path of greatest resistance from my point of view, which I find not very likely. It would have gone through the area of the Little Colorado and then just went around it. Okay. So Michael's model, in this case, proposes a time of mountain building while the river, the Colorado, was already there. It's a model of aggregation of material. The material is, of course, provided by close encounters of cometary planetary action, as it was already discussed before, basically filling the air with a lot of material, the atmosphere, so that it was available for the aggregation. The river, which was already there, prevented, where it was flowing, the aggregation. So basically, the canyon is growing around the river, thus creating the canyon itself. It's a different model. It's not so much about erosion, it's about aggregation and prevention of aggregation. Electricity might have played also a big role in the creation of the layers that we see. We'll later see in some of Billy Yelverton's experiments some indications that this might have been the case. So the layering, kind of electrical sorting might have happened. Come on. Okay, there we are. Here's a more detailed map, and it seems that as a post-process, I would call it a post-process after the initial creation, something accentuated and expanded and developed the side canyons of the Grand Canyon. And this might very well have been done through a charge flowing through the river and through the canyon. The reason here also is, while saying this, because if you look at those canyons here and the available drainage area over here, there is not much drainage available for, let's say, an erosional pattern there. And on the south side, it's even worse because actually the landscape goes down to the south. So water would have gone the other way. So this is why Michael suggests that after the canyon was created, some electrical current charge went through it and helped with the development of the scallop walls and accentuated and widened the side canyons. Also, this electrical charge might have been responsible for the schist and granite at the bottom of the canyon. Because if a charge goes through there, it's constricted in the narrow space, the current density goes up, and this might have an effect on the material there. In fact, the model itself contains the ability of electricity to create rocks out of dirt and to metamorph rocks into different types of rocks. There is some support for this, experimental support. A guy named Michael Anaya from Colorado has done some experiments about this, and he was able to, for example, to create pegmatite, which kind of metamorphic granite, from dirt, just by running a current through it. So this is a different model of how rocks are created, even metamorphic rocks. So, but the electrical forces active here at Grand Canyon were kind of small compared to what was going on roughly 100 miles north at Zion. There we are. So this is Zion Canyon. On top we have shale, mud, below it various layers of sandstone, and at some point Michael thinks the whole area was sloshed, which means it was covered with sediment, which then later got cleaned out. So this is a map of the area, and you see something very odd here. Oh, sorry. So do you see those lines? What are those? It kind of looks very regular, as if something came from the south and basically ate the material, was eating into it, and creating those straight lines. If you look a little bit deeper into it, it becomes more visible, and the idea is that whatever came from the south removed the mud and shale on top of it, and basically eroded it electrically away. Okay, now we are looking at a satellite map of the area, and you can look at this color scheme here. So this probably up here is more or less untouched mud and shale. Here, has this light color, that's remnants of the shale, but it might have been morphed into more like pottery there. It's clay and stuff like that. It kind of hardened. It's bare of any vegetation. And down below here, that's the sandstone. So this is what the sandstone looks like at Zion Canyon. Really scratched, at least from the outside, probably also from the inside. This is another picture of the area. Notice this odd thing up here. So it's even one there, a little bit more. So what could this be? Michael thinks that it was a remnant of the mud and shale, which kind of melted before it could be removed, which then kept it in place. Okay. So now let's have a look at the wider area here. We have Kolob Canyon over here. By the way, this is still Zion. Up here, that's Kolob. You can see again those straight lines here going up in. The same thing we have over here. That's Snow Canyon. And also it looks like something really was hitting this area. So the idea basically is really something came from the south, something electrical, and hit those walls. And interestingly, everything to the north of those areas, or some places in the north, those areas, show basalt layers, tuff layers. Just an observation. If we look at the wider area, more to the east, again in satellite view. Oh, there it is. Here we still have Zion, and over here, basically, that's the staircase of the Escalante over here. Still, we see that this discoloration pattern, this light color, continues to the east. So the whole area seems to have been hit in this model. Okay, but let's continue first with Snow Canyon. This is a close-up view. You can see what I described before in this other picture. Here we have those relatively straight lines, which, by the way, seem to continue up here. It's even here. Yeah, what was that? I mean, if you look at it even in more detail, would water do that? Probably. If not, the problem is here it goes down. So if water would have done this, I would expect a similar erosion pattern to the north. It's just not there. So I think kind of the standard model there has some issues. Okay. So this is another picture. This is Bryce Canyon in satellite view. So there might have been other areas which were not hit dead on or perpendicular, if you want. So the effect was minor compared, and Bryce Canyon seems to be an example of such region. By the way, north of Bryce you will find a lot of basalt, tuff. Another example, this is Cedar Breaks, in the same area. Again, the same thing. There's a lot of basalt nearby. And here is a picture, basically showing it how it looks like. What you can see here is that still, because it was only grazed, more or less, not directly hit, there's still some sedimentary structure there. It's not that clear developed, and there's a little bit of vegetation there. So it was not that intense in those places. Okay, we're switching now to another topic, sediments. This is a map, sedimentary rock map of North America. A lot of the valleys in the southwest are filled with up to 20,000 feet of sediment. This is a lot. It basically means that we are only seeing the tops of the mountains. The rest is under the sediment. It's hidden. One method of sediment distribution we have already just discussed is this electrical removal and then redeposition at other places. Another option, of course, is the sloshing flooding event that I mentioned before. When the waters rush to the poles and also east-west, depending on what just happens, those waters are injected through the canyons into high regions, let's say up to 12,000 feet. when the waters go running up there, the sediment, basically from the sea, from the continents that are swept over, is suspended in the water. It then starts to create layers, and by depositing that sediment. And it's very interesting to see that. I can highly recommend the so-called sedimentology videos from Colorado State University. They did some tests with that in plumes, and we're looking at this, and it seems that when water streams with a given current and the current changes, it always starts new layers, free layers, and they are then developing in the direction of the current. So it's not something like slow deposition in standing water. That might be an option, but it goes more like this in several layers in parallel. It's growing. So you can have a very fast fill-in of areas with this sediment, which looks like it was probably millions of years that it took in the standard model. Those experiments show very clearly that it might have been much faster. Okay, also something we can see here in this map is there it is something like, you see this? This kind of a roundish structure here, and this continues up here, and it goes down, coming back to islands. So this is kind of it stands out here, some kind of galaxy shape actually, on the North American continent. And the galaxy shape, as we all know, is a very common discharge pattern. So could it be that some electrical event happened over North America which created those mountain ranges? It's an option. So let's look a little bit deeper in here. And this is a terrain mode of the centerpiece. And if you look into that, some kind of roundish structures here seem to stand out. So let's get a little bit deeper into those. So the basic idea is that some electrical event or succession of events created basically those mountains, removed older ones, and redistributed sediment all over the place. Again, look at those here, those here. So, 4 corners, that's basically the area where we think it kind of happened. To the right, you can see this smaller inner circle, which seems to stand out. By the way, shiprock that I showed on the first slide is very close to the center of this circle. And there seems to be a kind of outer ring here, which is also kind of showing up nicely if you look at rock maps of the area. It seems to be a basalt ring going around there. Also, what's visible here on the right side, just put it in, are the so-called fault lines of the Colorado Plateau. If it has something to do with this or not, I can't say. It's just giving you that information so that you have a perspective on that. So the event, kind of what Michael has in mind here, is like a vortex, think diachrotron instability over this area. That, of course, means we have vortices within vortices, counter-rotation, but the overall main direction of the main vortex seems to have been clockwise. We'll come to that. Also, what's a little bit odd here is the area around here a little bit, which kind of initially didn't fit, because what was that? The other areas seem to show a lot of removal of material. This area shows an aggregation. Okay, we just mentioned the basalt. That showing up nicely here as a ring. If you look at those from the standard model, those have a little bit of a problem because they are often there is no source to be found for the basalt. There are a lot of missing volcanoes involved actually in the standard model. So it's like they're there, and then some kind of very selective erosion process happens and removes a lot of basalt in between, and then the volcano, and especially the volcano, it goes with stump and roots, nowhere to be seen again. And this is kind of a strange model, I think. There's also something that is called welded tuff, basically also something that came from volcanoes, but is more like dusty stuff that is welded onto, in itself, onto material. Something like this. But also the welded tuff model in the standard description has a problem, that because often those sources for the welded tuff are roughly up to 100 miles away from the deposition. And the question remains, how does this material stay hot in the standard model to be actually welded at the deposition point? It's probably what nature does. I don't know. If you don't have any other option, you might come up with such ideas. I don't know. In Michael's model, streams of plasma, the so-called river of fire from the legends, was flowing over the surface of the Earth, and it could very well have kept this material, which was in the air, electrically eroded, coming from cometary material, raining down on Earth, and kept it hot, so that it actually, in the place where it was deposited, was still able to weld, actually. Okay, this is an example of the process, how it looks like. But in the EU model, Michael's model, it doesn't apply only to welded tuff. It is basically the main deposition process of all the other materials. May it be dolomite, basalt, tuff, sandstone, you name it, limestone. It's all being deposited like this on top of already existing obstacles. It is basically the main mountain building process in his model. If you want to find this place, this is at the south entrance to Death Valley, where this photo was shot. Here's another example. It's, I think, south of Pahrump. The dark gray is dolomite. Sorry. Yeah. The red stuff is the tuff. The gray, light gray, is shale. Again, if you want to find this was shot from Highway 170, up there, looking at those structures in the middle. Okay. So before I mentioned this place there in the four corners circle, where we had aggregation, and initially that didn't fit well. But later on, he came to the conclusion that this is actually deposition, clockwise deposition from the material that was removed at other places, Canyonlands and Moab and this area around it. So the area that's in question is basically the Grand Mesa, the Gunnison River, and part of San Juan's. That's, by the way, the Gunnison River with the Black Canyon. The Grand Mesa there is about 10,000 feet high. The standard model would like to see some kind of volcanoes in the area to provide for that basalt. They're looking for it north of the Gunnison. The area at the highest peaks is roughly around 11,000 feet high. And between the Grand Mesa and this area, there is a valley which has a height of 5,000 feet. So in order for the standard model to work, you would have to remove 5,000 feet of basalt without a trace to get it there. Think about that. Also, where's the volcano? That's the area where they are looking for it. I don't see it. We're still looking, even if we look a little bit deeper. I mean, there are peaks there, but nothing that looks like a caldera or something like that. Anyway, if this is a missing person case, we are delightful for any hints on where to look for it. Okay. Another topic which was a little bit visible here at the Black Canyon are quartz veins. They are, the standard model makes them a long ongoing hydrothermal process. Okay, the EU model, which is kind of catastrophic, doesn't have that amount of time available in those areas. So there is a replacement process actually needed in some way. And we think it's also electrical. Look at this, for example. This picture was shot at southeast, I think, of Domeland, which is just south of Yosemite. it kind of looks like the feathered discharge of a Tesla coil. So the idea is that quartz veins are aggregations, accumulations from a charge running through the earth. But this might not also affect silicon dioxide. Very often we find gold in those areas, close by those quartz veins. So maybe there's also some kind of transmutation involved. Also diamonds show up. So, okay, why do we think this kind of model has any merit? The last few months there was some very delightful confirmation by experiments done by Billy Yelverton. And confirmation in this case means it's not, we're not saying the process, it happened like this. It just says the experiments, the results of the experiments allow for it. So it's kind of an option. So what did Billy do? And I can recommend for you all to look at the videos. Roger Passon, I think at 7, will be showing them in the breakout room. And it's really interesting what happens there. I will be showing you just some stills here. So what did he do? He had an anode, cathode, electrodes being there, and he let material raining down from above. Think cometary interaction, having material in the atmosphere. He kind of tried to come up with an idea to what is going on, what's happening. So first thing we see here is that we have more aggregation to the left and on the right. Also on the right, we have some, not so much aggregation, but it looks like prevention of aggregation. Here's another example, different mix of material, more or less it looks like same deposition, but even stronger are those areas where there is no aggregation visible. To me, this one here looks pretty much like something that we also can find on the moon. So the reals on the moon might look like this. This is a different model. It's not so much in a model of excavation. It could also be something like prevention of aggregation. It's an idea. What's happening caused by those experiments. Okay, next one here. Next thing Billy tried was having water flowing here in a straight line while material was falling from the sky and electricity was flowing. What we can see here is that in the middle between the electrodes there is much more aggregation. And a detailed look shows this. What we can see here are kind of scallop walls. Also, there seems to be, if you look really, really hard, some kind of horizontal layering appearing here. The material from above was completely mixed. So there might go on some kind of electrical sorting going on, depositing it. Think Grand Canyon. A lot of horizontal layers there. Okay, next slide. This is kind of a control experiment. Put the electrodes to the side of the river. We still see some major aggregation at the water flow. Not so much around the electrodes. On the other side, we have what we would expect, simply deposition. So next one here is same thing, we have water flowing. This time, it was meandering. Different tests. Come on. So again here, I think the scallop walls here are really, really nicely visible in here. And think, if you put that to scale, what kind of canyon that would be. Also, again, these areas where we have prevention of aggregation. And the last slides of those experiments is a control experiment again. What happens if we don't put in the electricity? The results are quite different. So, to sum it up, the electric universe paradigm adds immensely being used to the tool set of geology for geologic processes. There are a lot more options available. You don't have to resort so many times to it's what nature does. And the described processes are able to resurface the Earth in a very short period of time. And last but not least, the scenario connects what we find on Earth with the catastrophic myths and legends. We no longer have to dismiss them as the standard model has to. Thank you.